In the early hours of August 6, 1945, a single aircraft flew quietly over the Japanese city of Hiroshima. There was no warning, no air raid siren, no defensive fire. At 8:15 a.m. a bomb detonated in the sky. In less than a second, the temperature at the center of the explosion reached several million degrees Celsius. Shadows were burned into concrete. Entire city blocks vanished. More than 70,000 people died instantly. The weapon that caused this devastation was not built in a factory or designed by a single inventor. It was created in secrecy by thousands of scientists, engineers, soldiers, and laborers working under extreme pressure, racing against time itself. This was the Manhattan Project. It was the most expensive scientific effort in human history at that point. It involved some of the greatest minds of the 20th century, and it permanently changed warfare, politics, and the future of humanity. This is the story of how it began, how it worked, and what it ultimately unleashed upon the world. The story does not begin with war. It begins with curiosity. In 1938, two German chemists discovered something strange while experimenting with uranium atoms. When struck by a neutron, the atom split apart, releasing a massive amount of energy. This process was called nuclear fission. Even more alarming, the split atom released additional neutrons, meaning one reaction could trigger another, and another, and another. A chain reaction. Physicists immediately realized the implication. If this reaction could be controlled, it could generate immense power. If uncontrolled, it could produce an explosion unlike anything ever seen. At the same time, Europe was descending into chaos. Adolf Hitler had risen to power in Germany. Jewish scientists were fleeing the country, many of them carrying critical knowledge of nuclear physics. Among them was Albert Einstein. In 1939, Einstein signed a letter warning U.S. President Franklin D. Roosevelt that Nazi Germany might be developing an atomic bomb. The letter urged immediate action. Roosevelt understood the stakes. If Hitler obtained such a weapon first, the consequences would be catastrophic. The United States began quietly funding nuclear research. What started as a small scientific inquiry would soon become a massive, secret wartime operation. In 1941, after the attack on Pearl Harbor, the United States officially entered World War II. The atomic program shifted into high gear. The effort was placed under military control and given a misleading name, the Manhattan Engineer District, later shortened to the Manhattan Project. Despite the name, most of the work would not take place in Manhattan. General Leslie Groves was appointed to lead the project. He was known for his strict discipline, efficiency, and ability to manage enormous construction efforts. Groves immediately realized the scale of what was required. Entire cities would need to be built from scratch. Factories larger than any ever constructed, laboratories hidden in remote locations, and secrecy above all else. Thousands of workers were recruited. Most were never told what they were building. Scientists were compartmentalized. Engineers knew only their small piece of the puzzle. Even vice presidents and cabinet members were unaware of the project's true purpose. Only a handful of people knew the full truth. At the center of the Manhattan Project was a remote mesa in New Mexico. Here, a secret laboratory was constructed, Los Alamos. The scientific director was a brilliant, intense physicist named J. Robert Oppenheimer. Oppenheimer gathered an extraordinary team, Nobel Prize winners, young prodigies, theoretical physicists, and experimental engineers. They lived in isolation, cut off from the outside world. Mail was censored, phone calls were monitored. Families lived behind fences guarded by armed soldiers. Their task was simple in description, but terrifying in reality: design a working atomic bomb. The scientists debated constantly. Could it even work? Would the explosion ignite the atmosphere? Would the chain reaction stop or spiral out of control? There were no guarantees, only equations, experiments, and urgency. The bomb required an extremely rare material, fissile uranium or plutonium. Separating it was incredibly difficult. To solve this, the U.S. built massive facilities in Oak Ridge, Tennessee. Entire hills were leveled. Tens of thousands of workers operated machines they did not understand. Some methods used magnets, others used diffusion through porous barriers. All consumed enormous amounts of electricity. At the same time, another path was pursued: plutonium. Plutonium does not exist naturally in usable quantities. It had to be created inside nuclear reactors. At Hanford, Washington, Reactors were built to bombard uranium with neutrons, producing plutonium as a byproduct. The waste was radioactive. The risks were unknown. Mistakes could be fatal. Yet the work continued, day and night. Two bomb designs emerged. The first was a simple gun-type weapon, which fired one piece of uranium into another, creating a supercritical mass. This design became Little Boy, the bomb dropped on Hiroshima. The second design was far more complex. Plutonium behaved unpredictably. The gun-type method would not work. Instead, scientists developed an implosion design. Explosives had to be detonated with perfect timing, compressing a plutonium core evenly from all sides. If the timing was off by microseconds, the bomb would fail. This became Fat Man, the bomb used on Nagasaki. The complexity pushed physics and engineering to their limits. There was no room for error. By July 1945, the scientists were ready. A test was scheduled in the New Mexico desert. The site was code-named Trinity. The bomb was placed atop a steel tower. Instruments were positioned miles away. Bunkers were reinforced. On July 16th, at 5:39 a.m. the bomb detonated. A blinding flash turned night into day. The explosion formed a towering mushroom cloud. The shockwave knocked observers to the ground. Silence followed. Then cheers. And dread. Oppenheimer later recalled a line from ancient scripture, "Now I am become death, the destroyer of worlds." The bomb worked. Less than a month later, the weapon was used in war. On August 6th, Hiroshima was destroyed. 3 days later, Nagasaki followed. The explosions ended World War II. Japan surrendered. But the human cost was staggering. The project reshaped geopolitics, ethics, and science itself. It proved that human knowledge could outpace human wisdom. The Manhattan Project was not just a military operation. It was a turning point in human history. It showed what humanity could achieve under pressure, and what it could destroy. The same science that powers cities today once erased them. The question remains unanswered. Now that humanity holds the power of the atom, will it choose creation or annihilation?